With that, we then move to the second presentation by Walter Paniagua, who is going to talk about pile load testing in sedimentary rock, and he has some interesting case studies. Walter, floor is all yours.
Thank you, Gerald. Just a little clarification. I've been involved with DFI since 2000, since the large conference with European and American participants. And News Mexico, I'm from Mexico, is in North America. So sorry, I'm not in South America. Well, I have here 3 cases in sedimentary rocks. Here it is. Case 1, Cancun Airport wanted to build a new control tower for operations over there. And for all the people who sadly have not been in Cancun, it's in the Yucatan Peninsula, right where the red circle is. And it shares with Florida some problems due to limestone rock that it's over there. As you know, limestone rock suffers from karst phenomena, and sometimes they form cavities or underground flow that may dissolute the calcite and then make some voids in the rock. Getting into Cancun, the touristic area is over here in this L area where the beach is, and the airport is a little bit inland, not so far from the coast. And inside the airport, it was a busy one. Right now it has 4 terminals, the second airport in importance in Mexico, after Mexico City one. And here in the red dot, it's the new control tower. It's the highest in Latin America with 97 meters height. Well, the foundation was designed after careful soil exploration, and they have made borings beneath each pile with the concern of the karst problem. So they want to be sure that there were no cavities over there. And well, some anomalies were detected at certain depths. So the foundation was decided with this layout, and all the piles united by a slab in a 20 by 20 meter square. And soil exploration, I must admit, it was poor, especially the rock sampling. You can see some rock samples, if you can call them like that, here in the photograph in the right bottom. And unfortunately, they were not good. And as Sebastian just told us, the bearing capacity predictions are based in rock, at least in the unconfined compression test on rocks. So with this kind of samples, you can imagine there's a little to be to do with this. So the owner, this is a concession airport, the owner decided to do a scaled load test in here. The piles are 1.5 meters in diameter, but the test shaft will be done in 0.8. So I extract here from the soil report, geotechnical report, the difference between the compression and tension capacities in metric tons for 1 meter and 1.5 meters. So the test pile, 0.9, sorry, my mistake, and 16.5 meters length. The production piles have different lengths due to the presence of the cavities. Here you have the plan, the blueprint of the different lengths. As you say, there are so many, between 14 and 29.5 meters. And well, the testing was done by the old-fashioned static load testing with the arrangement of 4 reaction piles, one at the center, which is the test pile, a main beam, secondary beams, and they are all connected with these concrete blocks that are as well connected to the reaction piles through the rebar of the pile itself. The instrumentation, you may guess, is typical with load cells in the top of the pile, the scale and mirror that the ASTM standard recommends, and the dial gauges, as well as displacement transducers over there. We also put some telltales in the body of the pile. This test was made in 2009 or 2008, as I can remember. And here's a picture of the telltale that is fixed to the main rebar, and then with a small bar goes up to the top of the pile, and it's isolated with a PVC tube and with some thing here to prevent the concrete to go inside. And well, here are the results. Here is the load displacement curve, and this pile was loaded up in 1,500 tons, and it has a displacement of 4 millimeters. That's an interesting thing. For one thing, if it has 0.9 meters in diameter, is far, far, far from the friction that is supposed to be 1% of the diameter, and is very far from the displacement that may be caused by the erection of the end bearing capacity. And with the load transfer curves from the right, that is load and depth here, we can see effectively at 16.5 meters in depth, there is no end bearing capacity measured over here. And the modulus of rigidity or modulus of rate reaction, if you divide it here by the transversal area, that will be this value for the load and this value for the unload. And here our problems begin because the structural designer said the modulus of subgrade reaction is so high. So the structural design of the slab, it's all wrong. We will have to redo it. Please make the piles weaker, which is something that you don't want to do. So the design load after the journal report is almost 750 tons. And here at 1,500, we are far, very far. We don't know how much far, but very far from the ultimate capacity. And here I want to make a comment. We want to distinguish between the maximum capacity of the testing, that is here 1,500, and the ultimate capacity, which will be affected by a factor of safety or load or resistance factor, if you are working with the other Ph.D. criteria, and that is the ultimate capacity. We can predict or extrapolate some value after this curve using the chain method or something like that. But for this case, it was not needed. Now, a tension test, same arrangement, only you have to put a block on top of the test piles and test pile, and then invert the secondary and the main beams. The jacks for load and the load cells are now on top. Same instrumentation, so I don't want to get into details for this thing. And similar thing, design load is almost 119 tons, and here, far from the failure, or not failure, far from the ultimate load, we are at 275 or something like that. So the main reason for this, I will say, will be the poor sampling of the rock. Now, second case, we are now at the north of our country. The sedimentary rocks that we found here are almost shales and limestones. And I want to talk about these buildings, the Croma Levana buildings. Monterey is close to the border to the US. And inside Monterey, here is the Valley of Monterey. And this site is outside of that valley. It's in the San Pedro Valley. This is a very, very high residential area with fancy buildings and stores and residential houses and so on. So this client wanted to build 2 towers, 29 floors, 130 meters height almost, very fancy, elegant, expensive. There's a good, nice golf course around here. So they want to put, we're not afraid to put some money on testing. And the soil exploration was also very poor. Here we have intercalations of silt, clay, and fracture shale. And after this depth, intercalations of fracture shale with different colors. There, the water table is over here, and there is an excavation for basements. So the piles are really with concrete and reinforcement steel from here up to this depth. So the option one was to make a slab and beams that were founded on this shale, but after some considerations, they decided to do well drift shafts over here. And the rock samples, the results, here you can see at several depths and some average values of the unconfined compression testing. The arrangement of the load testing, the static load testing, is similar to the previous one, both for compression and tension tests, so I will not want to go in more details after talking in the previous one. And here we have also the load displacement curves and load transfer curves for a compression test. As you can see also at this depth, this is the depth beneath the excavation, there is no end-bearing value that was measured over here. So I want to make a reflection on this. If we assume that we can develop all the end-bearing capacity, we will have a large displacement. So that will not be allowable by any structural or any common reason engineer. So you want to live with friction only. That will be, for development of friction, 1% of the diameter. And that's precisely what we are measuring here. Again, we have the maximum load here for the test, but not the ultimate load. So for evaluating the allowable load, it has a long way to go up. Case 3, some office buildings in Monterrey in the same area. And I will not go again with all the explanation of the load testing arrangement, but we have tested 3 piles with different diameters, 1.8, 1.5, and 1.0 meters each pile. And here is the allowable bearing capacity, 826, for instance, for pile 1, with the allowable sediment, 10% of the diameter, which is a lot. And we are here about 1,000 tons. And also the perhaps we can have some ultimate bearing ultimate load in this graph, but not in this one, and not certainly in this one. So again, I think we should design basically on friction and have the end-bearing capacity as a reserve for certain things like construction failures, if you are in a seismic area, seismic loads or wind loads or any accidental load that you may have. But we are mainly wanting to design with friction because the displacement is so small and it's allowable for both structural and geotechnical engineers. Well, the general comments is that the load testing showed a huge underestimation of compression tension bearing capacity, as well as the modulus of subaggregate reaction. And with this underestimation, if you take the actual values that were showed in the testing, you will save a lot of money, between 2 and 2.5 times the amount of money that were initially planned. My perception is the problems in design started with poor rock sampling. Other methods, especially in the shale, will be using the pressure meter testing and trying to evaluate the bearing capacity through these methods. And well, finally, load testing proved to be a reliable method for an optimal design for foundations, but you should be aware that there should be an unbalanced amount of money between testing, should be a little bit, and the amount of savings, that should be a lot. If you are in the other way, with a lot of cost of the testing and so little savings, you are in the wrong side. And with this, I finish. Thank you, Gerald.
Walter, thank you very much for a very interesting presentation. And I apologize putting you in South America. Obviously, Mexico is in North America.